right, so first things first today, we're going to do is work on the Chapter 8 problem set. And then if that doesn't take up the whole class, then we'll carry on with Chapter 11. All right, so let's get this thing going. Let's see, here we go. All right, so we have the box. All right, now the box is here to make it simpler to fill in your results. So you can see them all together side by side and see the connection between these different values and the results that we're getting. So you don't have to put your answers in the box, but I think it's a good idea since it's there. But why don't we go through and do all the calculations. First of all 8 of these questions are based on the simple interest formula. I equals PRT. Yes, we've seen this many, many times before. And so we're going to see it here many, many times again. So in the first case, we'll see that we're being asked to calculate the simple interest, right? So in question 1, what do we know? We know that P is 12,000, R is 0.06. So make sure you replace those percentages with decimals, and T is 2 years. And since I equals PRT, that equals 12,000 times 0.06 times 2, which happens to be $1,440. Okay, so I'll put that right here, $1,440. All right, so you've got this one first. So these, as you can see, they're all pretty straightforward. All right. Let's see if I can squeeze this onto one line. Okay, that looks good. Number 2, same thing. We're being asked to calculate the simple interest. This one has a bit of a wrinkle, though, because the time is 6 months. Remember, that means half a year. Okay, so that's the only real trick to that one. Just replace the T, not with a 6, but with a half for half a year. All right, so we just multiply straight across. And that one works out to be $1,062.50. Okay, so I'll put that right here. 1,062.50. Now, number 3 is a little bit different because you can see that we're trying to solve for time. So you might recall that we were able to take these formulas and rearrange them algebraically. Okay, so let me just repeat some of these formulas up here. Since I equals PRT, that implies that T equals I over PR, R equals I over PT, and then finally P equals I over PR. I over RT, yes. So in other words, in each case, I've just taken the original formula and rearranged it algebraically to solve for what I need. All right, so let's do number 3. 3 is a question where we're asked to solve for time. So we're told that principal is 1,800, R is 10, and I is 360. So therefore, using the T formula, T equals I over PR equals 360 over the product of 1,800 and 10%. Now, for this one, you want to make sure that you use the parentheses on your calculator. So let me write it like this. Just remind yourselves that when you do this on the calculator, the denominator has to be contained within parentheses. Otherwise, you'll get the wrong answer. And that gives me an answer of 2 years, okay? Because that's 360 over 1,800, or 180 rather, which is 2 years. Okay, so let me fill in the box. So that means that the time frame was 2 years. All right, so far so good, I hope. And yes, these are very, very simple and straightforward for the most part. Number 4 is also another time problem. This time, though, the principal is 600. R is 4%. The simple interest is 72. So when we calculate T, we have 72 over the product of 600 and 0.04. And that's 3 years even. Actually, while I'm at it, I'll throw one more step into this one. There we go. Okay. All right. So we've got 4 more to go. Now the next one, number 5, is asking us to calculate the rate. So we're being told that the principal is 4,300. We're solving for R. T is 6. And then I is 1290. Okay, so now remember we're solving for R in these cases. So R is I over PT, which is 1290 in this case, over the product of 4,300 and 6. And so let's see what that is. 1290 over 1290 over 25,800, which is, let's see, 1290, 5%. Okay, well, that works out nicely, 5% even. Okay, so I'll put that answer right here, 5%. Although here I'm typing it as 5%, it's, of course, it's 0.05. And then 6, we're told, once again, this is a rate problem. T is 200, P is 200, okay? And then T is 3 years, and I is 45. So R equals I over PT. And that equals 45 over the product of 203. 45 over 600. And 45 over 600 works out to be 7.5%. All right, 7. Now, in these cases, we're solving for P. So we start with the rate of 0.09. In this case, T is 4, and I is 354.60. So P, in this case, equals I over RT. 354.60 over 0.09 times 4. 354.60 over 0.36, and that turns out to be $985. And then finally 8, R is 15%, T is 7 years, and the simple interest is 65,625. So therefore, P equals I over RT equals 65,625 over the product of 0.15 times 7. And that works out to be 62,500. Oh, for God's sake. All right, here we go. So these are the answers, and these are the reasons behind those answers. Okay, so. All right, well, it's a little messier than I thought, but let's see what I can do here. All right, that looks good. Okay. All right, so what's next? So now we're looking for the future value of a loan using simple interest only. Okay. In other words, what we're using here is the formula A equals P times 1 plus RT. That's probably your quickest bet, although you can also still use A equals P plus I. But this is probably a little quicker. Okay. All right. So for the first one, A equals 800 times 1 plus. Now, in your calculator, this is going to be a little bit more complicated because what you have to do is use two sets of parentheses. So if not, what you could do is simplify before you do any multiplications. So in other words, 1 plus 0.04 times 5 is actually 1 plus 0.2. So rather than trying to do this with parentheses, what you can do is simplify it, and then the product here is quite simple. It's $960. So, you can decide what to do, but I think your best bet is always to simplify before you put anything into your calculator. It just reduces the risk of mistakes, especially when there's a lot of parentheses involved. And now here, for example, we have 15,000 times 1 plus the product of 9% and 7 years. But that can be simplified to 15,000 times 1.63, which I think you'll agree is a lot simpler than trying to do this directly. So 15,000 times 1 plus 1.63 works out to be 24,450. All right, very good. Yeah, if there's no sense, you don't really have to write them out. You could leave it like that, or you could put them in. It's up to you. All right. Now for this one, A equals 700 times 1 plus the product of 0.10 times 0.6, or 700 times 1.6, which is 1,120. Okay, let's try that. All right, yes. So in other words, you may optionally want to simplify everything, especially anything that comes within parentheses. Parentheses are the biggest nuisance on the calculator. If you can avoid them, then you should always do that. And now finally, this one would be 1250 times 1 plus 0.085 times 6 months, which is, remember, 0.5. So you can rewrite this as 1.0425. Okay. Now this one does have dollars and cents. It's 1303.125, which you can round. Normally you would round this because it's a dollar amount, 1303.13. But either one of these is fine. Okay, let's see. Now, here we have a small group of word problems. And of course, the thing about the word problems is that they have to parallel what we've been doing with the algebraic problems. So, it's just a question of figuring out what exactly we're being asked to do. So, sorry. There we go. All right, so for example, right here, in addition to working and her family's contribution, Jane had to borrow $8,000 over the course of 6 years to complete her education. The simple interest that she pays is $4,046.40. Find the rate of interest. Now, the key here is that they're telling us how much simple interest she's paying. So that means this is just one of these formulas from up here. They're asking us to calculate this one, R. Okay, so that's how we know what kind of problem this is. The fact that they're asking us for simple interest or giving us simple interest tells us that we're using this formula. Now the principal is 8,000. The time is 6 years, and the simple interest is 4,046.40. Therefore, R is the ratio 4,046.40 over the product of 8,000 times 6, which is 48,000. So the ratio of those two numbers, 4046.4 divided by 48,000, is 8.43%. Very good. All right. So hopefully we all got that one right. All right, let's try this next one. Fred started up a new e-commerce business and borrowed $15,000 for 12 years to get the business up and running. The simple interest is 18,000. So this is actually the exact same type of problem. The only thing that's different, of course, is the actual numbers. All right, so this time, the principal you borrowed is 15,000. This is 12 years. And the simple interest is 18,000. So let's see what we've got. R equals 18,000 over the product of 15,000 times 12. And so this is 18,000 over 180,000, which is 10%. Okay, so 12 times 15,000 is in fact 180,000. So again, on your calculator, if you want to use it like this here, when you go from left to right, you do have to use these parentheses. If you do simplify it in advance, well then you're just taking the 18,000 and dividing by 180,000. Now here, again, this is a simple interest problem. It's a simple interest setting. They're asking us to find the principal. So let me just go grab that formula real fast. Okay, so what do we know? The principal is what we're looking for. So I equals 1350. The rate is 9. The time is 3. So we have 1350 over the product of 0.09 times 3, or 1350 over 0.27. And let's see what that gives us. $5,000. Okay, so it just means that the campus bookstore borrowed $5,000 in order to buy the copiers. All right, now for this one, again, this is a simple interest problem, but the word term, by the way, means time. Okay, so that means this is a time problem, and we're picking this one. Okay, so we know that I is 1282.50. P is 4,500, and R is 0.095. Okay. So we plug those in. Now, here, when we simplify, 4,500 times 0.095 is 427.50. And that's going to be 3 years. Okay. Now, this last one, this is also the exact same problem, the term. So here the interest, the simple interest is 441.15. And the principal is 86.50. And okay, 6.8%. And so we have 441.15 over 588.20, which works out to be 70 point. Now here, 0.75 means 0.75 years, which can be interpreted as 9 months. Okay, so yes, you can leave it as 0.75 years, but that is actually 9 months. All right, now these are going to be a little trickier because these involve compound interest. And you're being asked to do multiple things at a time. You're being asked to calculate the compound interest as well as the future value. So what exactly is going on here? This is the case where we have that very complicated formula for A. Let me just go get it for you or type it in. And so you can see it's our old friend A equals P times, in parentheses, 1 plus R over N. Whoops. NT. That's the formula we'll use in each case, but that's only for the future value. We also have to figure out the compound interest. So this is a multi-part process. So why don't we start by figuring out, so for number 18, we can start by listing the variables. P is 825, R is 0.04. Now the compounding frequency is the N in our formula. And then we have T equals 10. So we'll plug those numbers into here first. So we've got 825 times 1 plus, okay, over 1. And then up here we'll have 1 times 10. Okay, so first what we should almost certainly do is simplify this. This works out to 1.04 to the 10th power. And that's equal to 1221.20. So there's our future value. Now, normally we'd be done here if that's all they wanted, but instead we have to figure out the compound interest. So the best way to figure out the compound interest is to go ahead and say total interest minus simple interest. And the total interest equals the future value minus the principal, P. So here we have A minus P equals 1221.20 minus 1,000, which means that the total interest was 221.20. Okay, so, oh wait, no, sorry, it wasn't 820, it's 825, my fault. Hold on. 825, that's better. So the actual principal, or total interest rather, would have been the difference between those two, 396.20. Now the simple interest, as you know, from doing this enough times, I equals PRT would be, the principal is 825, the rate is 4, it's 10 years. And that gives me 330 even. So therefore the compound interest is the difference between these two, 396.20 minus 330 equals 66.20. And so finally we're done. All right, and there it is. So all of them are exactly like this. Let me give you a minute to catch up because every single one of them is exactly like this. All right, all the steps are going to be the same in every one of these cases. All right, so actually, let me start typing out the details from number 19. In 19, we have P equals 3250. R is 0.02. The compounding frequency is annually, and the time frame is 5 years. Okay. So the first thing we'll do is plug all this into our future value formula. I'll just edit this one. $32.50, the rate is 2. Compounding frequency is again 1, but this is now a 5-year investment. So when we simplify this, it's 1.02 raised to the 5th power which can be easily solved as $3588.26. All right, you know what the rest is. We're going to follow this exact same procedure every time, so I'll just copy these, and then we'll fill in the new numbers, okay? So here the future value turned out to be, as we saw, 3588.26. The principal was 3250, and that the difference between those two is 338.26. Okay, that's easy. The simple interest is very simple to calculate. We have 3250 times 0.02 times 5, which works out to be $325. So finally, we have 338.26 minus 325, which leaves us with $13.26. All right, so that one is done. So I'll give you a minute to catch up, and then we'll start the next one. All right, so let me start typing in the details for number 20. P equals uh, 75. Oh, 75, really? The rate is, this is a tiny little investment, 3%. And it's 2 this time because it's semi-annual compounding, and it's a 6-year investment. So I will copy this as usual and edit it. And let's see what we come up with. All right, so what do we have? 75, 3%, but twice a year is the compounding. So, and it also is a 6-year investment. So what we actually have here is the equivalent of 75 times 1.015 raised to the 12th power okay, 89.67 is the final result. Okay, so it's a small investment, but it grew to 89.67, and now the rest of the details will follow along what we did here. So future value again was 89.67. The original principal is 75. And that's going to leave us with total interest of $14.67. Now, the simple interest in this case is 75 times 3% for 6 years. And that would be $13.50. And so finally, the compound interest is the difference between the two, $14.67 minus $13.50, which is $1.17. Not much, but remember, we only started out with $75. All right, so I'll give you a minute. Okay, so for number 21, the details are these. Principal is 1550. R is 0.05. The compounding frequency is 2. And T is 7 years. Okay, great. All right, so let's use our magic formula here to find the answer. Okay, 1550. This is 5. 2 is the semi-annual compounding frequency, and then we have 7 here. So what we're doing here is actually calculating 1550 times 1.025 raised to the 14th power. All right. $21.90.11 will be your final answer here. And that's rounded, of course, to dollars and cents. All right, there's our future value, and the rest of it will follow along the same lines as what we've been doing. So here we have a future value of 2190. $11 minus the principal, which is 1550. And so the difference between those two is $640.11. The simple interest in this case is 1550 times 0.05 times 7. Wait a minute. No, times 7, sorry. It's 7 years. Okay, so 7 years at 5% times 1550 is 542.50. Okay. All right, and then finally the difference between them $640.11 minus 542.50 equals 97.61. Very nice. Okay. All right, now for 22, the principal will be 625. The rate is 0.08. Quarterly is the compounding frequency, and it's a 12-year investment. All right, so we'll plug those into the formula. All right, 625. 8% quarterly, so that's 4 down here, and 12. So we have 625, 1.02 raised to the 48th power. All right, let's see what that turns out to be. $16.92. Okay. Now, what about the rest of it? All right, so we have the future value 16, 92. The principal is 6 1/4. So that means with 991.92 for our total interest. Simple interest is 625 times R, which is 08, and T is 12. $600. So the difference between the two is 991.62 minus 600, which is 391.62. All right. So there is one more. You can see they're all exactly the same. So once you've gotten the hang of this, I mean, they're all, the only thing you have to do is just watch out that you don't make any typos in your calculator. All right. So let's try 23. Now 23, the principal is 25.75. R is 0.04. Quarterly compounding. And T is 2. All right, so I'll borrow this formula again. $25.75, 4%, and this is a 2-year investment. All right, so we have $25.75. Here we have 1.01. We have 8. All right, and what does that work out to be? All right, and then the rest will be so we have 27 minus 25.75, and the difference between those two is $213.36. The simple interest is $2,575. 4% times 2 equals $206. And then the difference between them is $736. Finally, all right, those are done. Now we get to do some annuity problems. Now these refer to that very, very complicated formula that we saw at the end of the chapter. Yes, that scary looking one. So in problem 24, we have a payment. Now R is the payment. A capital R, that is. Upper lowercase r is the interest rate of 9. The compounding frequency here is once a year, and it's a 9-year investment. Now that means because it's an annuity, this $200 takes place every year, not just once. So we need that much more advanced formula, which I'll put up here right now. A equals, okay, so we have to watch it with this one. R times one plus R over N to the NT power minus 1 over R over N. There we go. That's our formula. All right. So now for this one, all we have to do is calculate the future value. There's no other steps. We just literally plug everything in. Okay. Oh, wait a minute. What happened here? That's good. All right. So that'll be our formula for the rest of these problems. So let me just start. Actually, let me move this down here. All right. There we go. So let's plug it in. Now, this is the one case where you really do need to do some simplification. Otherwise, you're almost certainly going to have problems unless you're exceptionally good with the parentheses. So we'll plug in the numbers. Remember, we had a $200 payment. The interest rate is 0.09. It's annual compounding. And it's a 9-year investment. Down here we have 0.09 over 1. All right, so what can we do with this one? Well, this one simplifies pretty nicely. 200 times 1 in parentheses, or brackets, I guess. Not that it matters. They both mean the same thing mathematically, but we could reduce this to 1.09 to the first power, a 9th power rather, minus 1. In the denominator, of course, we have 0.09. Okay, so from here to here, that's where all the simplification should be, make things a lot simpler for us. So that being the case, what we can do now okay, let's get rid of some of these steps. So 1.09 to the 9th power is equal to approximately 2.17189. I guess that should be plenty. I'll take it out one more place. I think that should be enough to give us a reasonable degree of accuracy. So actually in the numerator have 200 times 1.1718933. Down here you have 0.09. So this ratio equals, let's see, 234.378656. Because these are dollars and cents, you don't have to go berserk with the rounding, but the more digits you have, the better, I think. And that's going to turn out, if you round this to dollars and cents, it's going to be approximately 2604 point, let's say 21. Okay, so just be aware that whatever happens, no matter how many decimals of accuracy you use, we only really need to get it to dollars and cents. Okay, so yes, it's a messy formula, but that's all we have to do. We're done. The future value is 2604.21. Okay, now for 25, we're told that R is 750. Capital R, that is, lowercase r is 3%. So the repeated payment is 750. The interest rate is 3%. The compounding frequency is annually, and the time frame is 12 years. Okay, great. So now I can just copy this and just edit it, and we'll have what we need. All right, so of course the first thing is to plug in everything correctly, then we will simplify. So we've got 750, and we have 3%. The compounding frequency is still 1, but this is 12 years. Okay, so you've got 750, and here we've got 1 plus 3% to the 12th power, all divided by 0.03. Okay, so now we can start doing something with that. All right, so I'll just grab this one and edit it. I think it'll be faster. All right, so we have 750. Now, 1.03 to the 12th power is roughly equal to 1.4257609, let's say. So then here we'll have 750 times point 4257609 over 3. All right, so let's see, this reduces to 319.3206651 over 0.03. All right, so finally we get our answer here. $1064.40. Oops. All right, so that's approximately the future value. Now, again, you might have a slightly different number. You might be off by a penny or two. If you are, it just means that you've rounded it slightly differently. Oh, wait a minute. Uh-oh, I think I did something wrong here. Sorry. I just, my fault. You're absolutely right. This is not correct. I was looking at the wrong thing. Everything's right up to this point, except the last part that I copied incorrectly. It's 10,644.02. Yes. Okay, now it's correct. That's better. Now we're good after all that work. It is within dollars and cents. It's 10,644.02. Wow. Yes, this is a bit of a headache, but we're doing it as long as you're careful. Now, again, I think the key to the whole thing is the simplification process that we're going through. If you try to do this directly in the beginning with the parentheses, it would be a nightmare. So to the extent that you can keep simplifying it, that should help reduce a lot of errors. Okay. So, all right. So what about the next one? What's going on there? 26. The numbers that we were given are 1250 is the payment. And then we know that the rate is 6.8%. And it's semi-annual this time. And for 3 years. Okay, so let's do it. All right, so I'll just borrow this one and I'll do some editing on it. Okay, so this time we have 1250. And this is for 6.8% twice a year for 3 years. Okay, so down here we have the same thing in the parentheses, 068 over 2. All right, so we've got 1250, 1.034, and here we go. Okay, all right, now let's continue to simplify. So that means we're going to have 1250 in the brackets, 1.034 to the 6th power. Oops. Is approximately equal to 1.22, 222.146.399 minus 1. Again, you don't really necessarily need all those decimals, but because we're rounding to dollars and cents. But you know, you can have more is usually better, but you know, we only have to go so far. 0.222.146.399 over 0.034. And so now when we multiply the numerator, we get 277.68. That's pretty much exactly 3. So let's round that to 3. And finally, when the dust settles, we're going to end up with approximately 81.67, 15, let's say 14 or 15, depending on how you rounded it. All right, wait. Yeah, it's somewhere between 14 and 15 cents. Either one is fine. Okay, 27. Yes, there's a 27. Let's see, what do we know this time? R is 375. Capital R, that is, lowercase, 5%. Then we have quarterly compounding. and 4 years. Okay, so that's our next problem. All right, so I'll just borrow this formula and recycle it. $375. Now, it's 5% compounded quarterly. Okay, and in the numerator, n times t will now be 4 times 4. Okay, so 0.05 divided by 4 is 1.01. Oh, made a typo. 0125, sorry, raised to the 16th power, and that's divided by 0125 again. All right, now we can just simplify it a little bit more. Okay, and what do we get? All right, so we have the ratio of 375 in the brackets. 1.0125 raised to the 16th power is equal to about 1.219889548, let's say. All right, and then when you multiply that, or actually, no, sorry, I almost missed the subtraction of 1. That's better. And then what you've actually got here is the ratio of 375 times 0.219889548, all divided by 0.0125. Okay, let's see how that works out. So the ratio you've actually got is 82.4585839 over 0.0125. And again, there could be some rounding differences, but you should end up with approximately 6596.69, it looks like. Yeah, that's good. All right. All right, so let me just, now there's one more, 28, where we have 1530. The interest rate is 4.5%. It's quarterly compounding, and this time it is for 8 years. All right, so borrow this formula and plug in the correct numbers. 1530. The rate of interest is 4.5%, compounded quarterly for 8 years. Okay. $1.01125 is raised to the 32nd power, and that's divided by 0.01125. Okay, because 4.5% divided by 4 is 1.01125. Perfect. All right, so let's simplify it and see what we get. right, so let's see. We've got 1530. And in parentheses, 1.01125 is raised to the 32nd power. All right, so we've actually got 1.43045 minus 1, all divided by 0.01125. All right, let's see. That's 1530 times 43 45 1402. Okay. So in the numerator, we have 658.5906457 over 0.1125. And that's going to give us roughly 58,000, 541.39, let's say. That should do it. All right, so those are done. Now, those, of course, are the most complicated formulas. The ones that follow are not anything like that in complexity. Now, then the next batch of problems, we're looking for the EAR formula. All right, so let me remind you what that looks like. So the EAR, let's type that in there. In this formula, we use E for EAR. And so we have 1 plus R over A raised to the nth power minus 1. All right, so remember how this works. E is EAR, R is APR, lowercase r is APR, and N is compounding frequency. All right, so therefore in 29, what do we need to know? Well, the APR or R is 0.06 and N is 4, and that's all you need to know. That's it. That's the entire formula right there. All right, so let's find out how this turned out. 1 plus 6% over 4 raised to the 4th power minus 1. So basically what you have here is 1.015 to the 4th power. I guess we could write it like this. 1.015 to the 4th power minus 1. And let's see what that turns out to be. 0.15 to the 4th minus 1. It's 0.06, 136, let's say. Actually, let me put parentheses here. It looks nicer that way. All right, so it's 6.136%. All right, so in other words, if the bank gives you a quote of 6%, but they tell you that the compounding is quarterly, this is what you're actually earning on your bank account. Okay, not 6, but 6.136%. All right, in question 30, they give us a rate of 10 and an APR actually of 10 and a compounding frequency of 2. So let's get that one going. Okay, so it's 10%, 2 years, or 2 periods. So that gives us 10 in the numerator. Down here we have 2. The exponent is 2. So we've actually got 1.05 raised to the second power minus 1. And that gives us 0.1025 or 10.25%. All right, so in this case, the bank account, you're earning 10.25% instead of 10. All right, 31, R is 0.065. N is 4. All right, let's do that again with different numbers. Okay, now 0.065 divided by 4 is 0.01625. That's raised to the 4th power. And so that's approximately equal to 0.0666. That's good enough. 6.66%. And then finally 32, there's one more. 32 is a rate of 9.55% with a compounding frequency of twice a year. And so that gives me okay, 0.0955 over 2 raised to the 2nd power. All right, so in the parentheses we have 1.04775 raised to the 2nd power and we have 0.09778 or 9.778%. Very good. All right, so those are all done. So what remains is a handful of word problems. And again, the challenge is to make sure you know which one they're referring to. By the time we get to this point, there's a lot of possibilities. So let's see, what is 33? They set aside $5,000 in the savings account. That's the principal. Compounded quarterly, and is for 10 years. The rate is 9%. So they're asking us for the future value. So that means, let's go way back up here and find this formula. Not that one, that's for annuities. This one. Now, the key to the whole thing here is that this money is only being deposited once. It's not an annuity, so be careful about that. They're saving the money once. Okay, so the question is, how much will they have in those 10 years, at the end of the 10 years? So we'll plug in all the numbers that we need and come up with the answer. So we've got 5,000. And let's see, the rate is 9. The compounding frequency is 4, and it's 10 years. So when we simplify this, we have 5,000 times. Now, 9% divided by 4 is 0.0225. So we actually have here 1.0225 raised to the 40th power. And when you multiply that out, so what you can do is multiply 5,000. You can do this directly on your calculator. The alternative is to figure out what's going on inside those parentheses. It's approximately 2.435188965. But either way, you're going to end up with about 12,175.94. All right. Oh, you know what? I guess there's room for that. Yeah, that's fine. Just want to make sure there's enough room on the page for it. Okay, now here, in order to pay for college, the parents of a child invest $20,000 in a bond. The interest rate is 8%. The compounding is semi-annual. And then again, they want to know how much they'll have in 18 years. Time is 18. So it's really the same exact problem, except with slightly different numbers. So let's plug those in. All right, so this time it's 20,000. There we go. 20,000. And the rate is 8. Compounding frequency is 2. And this is for 18 years. So 20,000. And here we have 1.04 to the 36th power. And so 1.04 to the 36th power is approximately equal to 4.10393255.4. That's good enough. And then when we multiply that by 20,000, we'll get our answer, which is 882,078.65. Perfect. All right. That's that. All right. So let me leave it there for a minute so you can catch up. All right, let's start taking a look at this one. We have a husband and wife. Ooh, now this one's different because it's an annuity. They're going to, they need to save money for 4 years. They're going to buy an annuity, which is an investment product that provides an annual cash flow for 4 years, the semi-annual compounding. The rate is 7.5%. And the regular repeated payment is $22.50. This is an annuity. They're putting away $22.50 twice a year for the next 4 years. So how much will they actually have in 4 years? Okay, so I'm going to go back and grab the annuity formula. And then we'll do that one. Let's see what happened. I think I went right past it. There it is. Okay. All right, so we'll just plug in the numbers as usual. But this one, of course, requires a lot of simplifications. All right, so we know in this case that it's a $22.50 payment. The rate of interest is 7.5. N is 2. Wow, what a mess. All right, so let's see what it simplifies to. 2250, 1.0375 is raised to the 8th power. Minus 1, all divided by 0.0375. All right, so let's see. 1.03, let's see. 1.0375 raised to the 8th minus 1 is equal to 342470784 divided by 0.0375. All right, and that's going to give us about 20,548.25. Yes. Okay. Ooh, boy, that was long, wasn't it? Okay. Now, finally, there's one more, and this is also an annuity problem. And what are we being told? A business owner wants to buy an annuity to pay for new copy machines in 3 years, so T is 3. The capital R of the payment is 600. Quarterly means that the compounding frequency is 4, and the interest rate is 8%. Okay, so we know all of that. We also know that we're going to calculate the future value of an annuity. So we'll use this formula. I'll just borrow this one and recycle it basically by replacing all these numbers with the new numbers. $600, 8% for and n times t. That would be 4 times 3. So that's 600 times 1.02 raised to the 12th power over 0.02. And let's see what that gives us. Zero point 268241795. All right. $8,047.25. All right. Well, it's hard to believe, but we're actually done. Boy, that was an ordeal, wasn't it? Yes, but now you're experts in this material, which is great because the next midterm, whenever it shows up, is actually going to be based entirely on this content. That was long, yes, that's true. But you've had tons of excellent practice. And that's really the bottom line, isn't it? Yes, it is. So now, man, what a day. The rest of the day will be a breeze by comparison, won't it? Yes, it will. Okay. And that's kind of nice. All right, so I guess it's just about 10 o'clock. I guess unless there's any last minute questions, I think we can go. Of course, I'll post this on Moodle when we're done, and then you can look at it and go through and make sure you got all the right answers. And other than that, when we meet again on Thursday, we'll be going right back to chapter 11, which we just started the other day. And that is, of course, our discussion about probability theory. There's more videos that we have that I want you to see, fun videos, that is. And so, probability theory is a very interesting area. So we'll take care of that on Thursday. So other than that, I guess I'll see you all on Thursday.
Thank you.
Thank you.
All right, see you then. Bye. Oh, we have one more. Okay, have a good one. You too.